Welcome everyone. I'm going to be talking about ShiftLeft Ocular today, which we call the Google Maps for auditing your code. And essentially what it is it's a search engine for vulnerability discovery. Well, I've actually been doing this stuff for quite a while now. Here's a bit about me. I started off as a vulnerability researcher for a company called Recurity Labs in Germany. And back then, it was all about taking code in all sorts of formats, so binary code, source code, or simply not having code at all, and just looking for security issues with that code. I guess at some point, I was fed up with the fact that there are so many repetitive tasks, things that we should be able to automate. And so coming from that background, I then went back to university to essentially find out whether I could build myself some tools and methods to make the job of a code auditor, a vulnerability researcher, more pleasant, less repetitive, to automate the tasks that come up again and again. And so I did my PhD on what then eventually I called pattern-based vulnerability discovery. And in that thesis, I combined static analysis with machine learning. And now you might think, okay, machine learning, that sounds like it's not going to work. Actually, the main idea there was to say, you can't use machine learning as something where you just throw in whatever data you have and then hope that it gives you good results. You actually need to throw in something that, in which you could also find these patterns as a human being. And so a lot of this thesis is about how you extract meaningful features from code. And part of that work led to the development of an open source code analysis platform called Yearn. And so Yearn would construct a graph of your code, import that into a graph database, and then you would be able to query that graph for interesting patterns in your code, and specifically for patterns that are related to vulnerabilities. Once I was done with my university career, I went back to the industry to then again actually build this for real, as opposed to just as a research prototype. And that's where I am now. So I'm currently the chief scientist at ShiftLeft Inc., where I would say the motto is, well, we build different things, but one of the mottos is definitely, let's build this Yearn tool for real, as opposed to just a research prototype. And this Yearn for real, we call this Ocular, and you can check it out at Ocular ShiftLeft.io, or you can also get a free trial of this at go.shiftLeft.io Ocular free trial. What I'm going to show you today is all based on that free trial. So if you download this, then you can reproduce all of the things that I'm showing you today. So what is Ocular? It's definitely a tool for highly technical users. So this is for people who want to explore code, people who have audited code before manually, but they want to be quicker at this. Right now, it supports Java, C#, and C++. And the C++ module is actually based on the open source work that we did earlier with Yearn. And this is going to be released by end of month as open source as well. So there will be a complete Ocular-like system that you can use, which is open source as well. And what you can do with Ocular is you can understand your program structure in the attack surface. I'll show you that in a minute. And then you can formulate patterns related to vulnerabilities and see if the code that you're dealing with fulfills any of those patterns and therefore is possibly vulnerable. So the basic idea we follow is while it really isn't possible to automate vulnerability discovery entirely, what we can do is we can automatically extract all sorts of information about the code. And if you look at the kinds of representations that you get for code, most of them are actually graphs. So what you see there on the right, those are the kinds of representations that compilers work with. You have a syntax tree, for example. and a syntax tree, which is essentially a decomposition of the code into its language elements. Then you have what's called a control flow graph. If you've worked with reverse engineering tools like IDA Pro, you know this one. So this shows you how you can get from one statement to the other, under which conditions. And then you have something like program dependence graphs. Those show you some data flow. So are there any variables that are set which are used at another point and nothing happens in between? And a lot of other structures like the dominator tree here. Yeah, and then there are more high-level structures like, for example, type hierarchies, where you can simply see which type derives from which other type, call graphs, all these kinds of things. And so each of these graph representations gives you a different view on the code. But they're all talking about the same code. So that's nice. What it means is that there are natural points in those graphs where you can connect the representations. So for example, for each statement in the code, there's a little subtree in your syntax tree. And also, for each statement, there's one node in that control flow graph. So the idea is, why not connect them together? That way, you get all of these different perspectives on the code, but also you get a way of naturally jumping from one perspective to the other. And suddenly, you can use all of these different views to describe patterns in your code. You can talk about the syntax of your code, about the control flow, the data flow, and many other aspects. What we had with the open source tool Yearn was essentially the lowest layer that you see in this, what we call code property graph. And that contained more or less the kind of data structures that you would have in a compiler. So syntax trees, program dependence graphs, control flow graphs, dominator trees, these kinds of things. And now based on that, well, we connect higher level representations of the code. So methods, types, call graphs, type hierarchy, but then also data flows. So we actually use a taint analysis engine to extract data flows and then represent those data flows as graphs or paths in the graph as well. And then finally, we even add things like configuration files for example, when methods are annotated such that you know, oh, this is an HTTP handler, and this and that is the route to that HTTP handler, then we read that from the configuration file and integrate that information in the graph as well. So the overall idea is take all of these different perspectives and make them available in a search engine so that people can actually write queries about their code that express specific types of vulnerability patterns in their code base. And in the trial version, you have these first two layers here. The layers above here, those go more into the direction of automatically finding things for you. And so these are not available in the trial version, but in the full version only. All right. So that being said, most of this talk is actually going to be a demo. And I'm going to demo on a project called OpenRefine. So OpenRefine, at some point, Google Refine, I think, is a program that journalists use to essentially refine their data, meaning to clean it up. And all it's supposed to do is read text files in different formats, in different packaged into different archives, and well, produce cleaned up versions of these. So from an attacker perspective, imagine you're a journalist, you want to attack that journalist, you send them some data where you tell them, you know, this is interesting data, and now if that file somehow creates a scenario where instead of just being read, it actually executes arbitrary code, then you have control over the, well, computer of that journalist. That's the attack model, if you want. Yeah, and so what I'm going to show you now is how you load this code into Ocular and how you start exploring the attack surface. So how you start from 0 to find out what can I actually attack here. All right. Okay. So there we go. So with Ocular, you have a tool called Java to CPG, and this is a tool that takes Java code and creates a code property graph from it. Now, when I say Java code, I actually don't mean source code, but I mean Java bytecode. And in the tradition of Yearn, what it actually accepts is anything that kind of looks like a valid Java archive. So really what it is it's a zip file containing class files of some kind. And if it can somehow find out that this looks like valid code, it will process it. And if it can't, then it will discard it. And so if you download OpenRefine, you will actually see that it does not come with a nicely packaged archive. So what I did was I just extracted, let me see. Yeah, I just extracted OpenRefine into this directory here. And now I'm going to create myself a jar file by just saying, find me all the class files, zip them together, and call that OpenRefine jar. So it is a jar in that there are class files packaged in a zip, but that's about it. And Java to CPG will happily process it for you. OK, so now I'm going to run Java to CPG on this, so on the OpenRefine jar. And you can now specify which packages you want to work on. Wait, let me just see. Quick look. Yeah, so org OpenRefine. And since we know this used to be at Google, Google is actually also a package that we want to process. All right, and so I'm going to time this. I think on this laptop, the construction of the graph takes about 16 to 20 seconds, something like that. Let's see. And so it's telling you the different packages that it's including. And now it's done. OK, so that was 17 seconds. OK. And now we have that graph. And let's just take a look at the graph first. So there's a file called cpg-bin-zip. And so we have a graph, and it's about 15 megabytes in size. And now we can load this graph into Ocular. Now, since we're doing this for the first time, it's going to do a bunch of initial calculations on the graph. When you do this again, these calculations will not be carried out. It now does some analysis of the graph to up-level it a bit, to calculate some additional information that will make traversals a bit faster in the future. All right. OK, let me just quickly look at my notes while we do this. OK, yeah. OK, so now the CPG is loaded. Can you see this well? Good? OK. Maybe a bit bigger. There we go. OK. So now you have that CPG, and now we can start exploring, for example, what are the type declarations that we have in that CPG. You can ask for the full name. And you'll see, OK, so these are all of the types that are used in OpenRefine. These are both the types inside the OpenRefine code, but also just types that are being referenced. So for example, Java long is going to be something that's just referenced. Now we can also say, please give me only the external types. These are only the ones that are referenced. And as you can see, I have beautiful tab completion, which is important when you type a lot. And yeah, here now we can see different kinds of libraries that are being used by the OpenRefine tool. To get a better overview, we can go from the type declarations to the namespaces. We can look at the names. There we go. Now we have the names, and we can deduplicate them. OK, and we can sort them. Wait, let me do it this way. Sort it. There we go. And now we see all of the different libraries that are being used in there. And so one of the things we can do when we have an overview of the libraries is to ask ourselves, what are the typical vulnerability patterns that you would expect when somebody uses those libraries? And so we see Jackson data bind. So you immediately think, OK, JSON deserialization vulns is something that we can look for. But then there's also Java util zip here. So anything related to archive processing is interesting. And there's XML usage here. So XXE is something you might want to look for. And we're actually going to look for two things now, one of them being the Java archive-related path traversals, and the other one being XXE vulnerabilities. Okay, so this gives you an idea of which libraries are being used. What you can also do is you can see how the application interacts with the outside world. So you might ask, are there any types that have anything to do with HTTP or HTTP, maybe like this? And you see, yes, there are a bunch of those. Let's take a look at them. All right, OK. So there's HTTP servlet request. And if you've audited a Java application before, you know, well, this is a request that comes from the outside. So this is possibly something that the attacker would control. And now we can ask for all methods that have parameters where the evaluation type is HTTP servlet request. So there you go. These are all, these are all parameters of methods with eval type servlet request, and then full name, and you'll see, okay, there are a bunch of those. Now, some of them might just be passing the servlet request from one method to the next. So we're interested mainly in those which have no callers. So we can also say filter not call, what is it? Just a second. Yeah, call in, there we go. So give me all the parameters with evaluation type HTTP servlet request. Go to the methods and filter such that there are no incoming calls. Are there any of those? Yes, there are 115 of those. Okay. And now we can actually look at their names, deduplicate those, and have a look. And what we see is the OpenRefine code base actually follows standard naming conventions. They have a lot of methods called doPost and doGet. So those are handlers of post and get requests. And they have a few others where they kind of did not follow the naming conventions. There's actually a doPut and a doDelete method. Nice. So there's something that actually also reacts to put and delete HTTP requests. Yeah, and that's that. So now you know anything that comes in through these, there is actually communication, HTTP communication with the outside world. And so this is where your attack surface is. All right. OK, so that's kind of like getting a basic overview with Ocular. Now let's actually find some vulnerabilities. Let me check the, yeah, I have enough time. All right, so zip-related vulnerabilities. This is actually a pretty old bug. First described in FRAC in the year 91, and recently rediscovered and branded as ZipSlip in 2018. So essentially what happens here is that you have an archive, and if the archive name contains .. then you get a path traversal. You can get a path traversal. So let's look at what this would look like in Java. So in Java, with that library Java util zip that we saw as being used, there's a method called zip entry get name. And if that name propagates to a file constructor, which has a path in its parameters, then and nothing happens on the way, then we have ZipSlip, as we say today. So this would be an example of that. So entry get name goes into the constructor, and there's your vulnerability. What can you do with this? Well, you can create files anywhere on the file system. So think of, for example, creating a file somewhere in a place in the HTTP root, PHP file or something like that, and then the attacker calls it from the outside, and arbitrary code is being executed. Or yeah, you can't overwrite files, I think, but yeah, that depends on the specifics of the programming language. All right, so let's check for zip-related bugs. where are we? Zip slip. There we go. Okay, so the first question to ask is, wait, is there even a method called Java util getName in the code base? And we ask, and we see, yes, this is being referenced in at least one point. Now we explore the call graph and we say, are there actually callers of this? And we see, yes, there are callers of this, but not too many. If we look at the size, it's only one. And the method that does that is called explode archive. So, and this seems to be an import handler. So there's a method called explode archive that will eventually call Java util zip getName. Now, that's the source. Now let's look for the sink. We just said the sink should be Java util zip, and then something called file, full name L. Oh, did I mistype? Java util, oh yeah, I did. There we go. Yes, and we see there are different ones here. Zip file, no, Java util, no, Java, sorry. I should look at my notes more. Java IO. IO Java, Java IO. I'll take a look at my notes. Java IO file, that's it. And I just forgot this one. There we go. Right, so file constructors. Let's actually look for init here. There we go. So we have two file constructors. We can see there's the one constructor that just takes a path, and then there's the other which takes a path as a second argument. And so what are the sinks? The sinks are the parameters that have an eval type of, let's see what eval types there are, IO file and string. So the eval type should be a path, so let's make this string. There we go. Great. Name, I guess. There we go. Okay, so now we have our sinks. And I'm just going to call this sink now. Okay. And the other thing was zip. No. Java util zip getName, this one. Yeah, exactly. So this one, let's look at the return values of this. That is the source. So var source is this. And now we actually explore the data flows. So for now, this was all call graph and a bit of syntax. And now we look at, I'm already just closing the whole thing. There we go. There we go. So we can say, give us all the sinks that are reachable by that source and list the flows. And maybe pretty print them. There we go. And now we see there are lots of flows. Now, usually you would have a bigger monitor to do this. I'm going to zoom out just so you see what this actually looks like. So you get a nice table of the flows. And you can actually see, well, you can't see it now, but I can see it here. The first line is getName. And eventually it propagates to the last line, which is that file constructor. So yes, we have a flow from zip getName to the path that is specified in the file constructor. We actually have a bunch of those. Now the other thing that you want to look at is whether, wait, there we go. Whether any of this, whether anywhere on that flow you pass through a method that looks like it kind of sanitizes that data. So it might say escape, sanitize, contains, substring, these kinds of things. Anything like that. And if that is the case, then you might not want to pass on this finding to a developer because you're thinking, well, it might be unsafe, but probably it isn't. So they will just say it's a false positive. Let's give them one of the flows that really looks like nothing happens on the way. And so here we can just say flows, passes not, escape, sanitize, contains, substring, and so on. And we see, well, there are two flows of this kind left. There we go. So there really is something unsanitized going from getName to the file constructor. Okay. And yeah, to make things short, this was a vulnerability. We filed it. We got a CVE for it. should be fixed in an upcoming version. Okay, so that was an example of a data flow related bug. We also found an XXE in this, and I'm going to show you how. So when you look at those types, I showed you how to list all those types. You'll see that something called the XML input factory is being used. And then if you look at the OWASP, if on the OWASP, well, OWASP has a cheat sheet that will actually tell you how to use this securely. And to use this securely, you need to configure this XML input factory to say that you do not want to support DTDs. Now, I'm not sure if both of these need to be set or one of them, but as you'll see in a minute, none of them are set, so we're on the safe side, or on the vulnerable side, really. Now, what is an XXE? Just to make it short, it's now also in the OWASP top 10. It's been a pretty popular vulnerability this year. So if an attacker controls an XML file and DTDs are enabled, then the attacker can possibly execute arbitrary code. And so we will see whether this XML input factory is used in a safe way. And to do that, checking for XXE. There we go. Let's start like this. So let me start off by seeing that XML methods are actually used, so XML input factory in this case. And then on that XML input factory, well, let's look for methods called setProperty that also contain XML input factory. Yep, that exists as well. And what's the second thing? Oh, yeah. Let's look for all the calls to this. Are there any calls to this? Yes, there are. And we can see both calls. And we can see that in both cases, so here are the strings that are passed, the configurations that are made. And in both cases, these don't match the configuration that needs to be done. So yes, we are using the XML input factory in an insecure way. Now we can also actually check if there is a flow to this. I'm actually going to skip this now for time reasons. But what you'll find is, yes, there's also a flow to this. Yes, it can be triggered from the outside. And again, we filed a CVE for this. And so, yeah, this is a real vulnerability that was previously not known. OK. So with that, the way Ocular is designed, you saw me just use it interactively. And that's how we use it when we just explore a code base. But eventually, you have your queries that you want to run every time. And so what you can do is you can pass scripts to Ocular, and it will execute non-interactively. And you can pipe out the results that you get as text, and also in different text formats, like, for example, JSON. So that then enables you to, well, use the query language only for the actual querying, and then switch back to your programming favorite programming language like Python or Ruby or whatever you want to use. Yeah, with that being said, let me summarize. So you saw a demo of Ocular on OpenRefine, formerly Google Refine. You saw that we take Java bytecode, that's an example really, to create these code property graphs. These code property graphs are actually, they look exactly the same regardless of the programming language you are processing, except for the names, of course, of methods. And you then saw how we discover dependencies in that code, how we discover HTTP triggers. And given that the dependencies were an XML processing library and the zip library, we looked specifically for path traversal vulnerabilities related to zip files and for XXE vulnerabilities. And we, or rather my colleague, Nico Schmidt, discovered and reported both of those vulnerabilities. So yeah, feel free to check it out. So there's Ocular ShiftLeft IO where you have documentation, a bit of a community site. It's all very new, but yeah, check it out. And then there's the free trial here that you can download. And everything I showed you today, you can actually do with a free trial. Yeah, with that being said, we have a booth here as well if you want to talk to us some more. And thanks for your attention.